Hello, and welcome back. Today we're going to be talking about variables. Set up just the bare bones of what we're going to be starting out with. Now, with any variable, the first thing you have to start out with it is the declaration. Now, the beginning of the declaration needs to be the type. We're going to get into a caveat of that in a second here, but for the current example, we'll start out with an integer. We are asking them to please enter a number, and we're going to start out with an integer, which is just a simple whole number. We're going to name it number, and that's it. We now have an integer variable named number that we can access from anywhere within this scope. Now, if you wanted to initialize this to a default value, we could do a space equals and then whatever we want it to default to, -1, whatever. Sometimes you want to do that, sometimes you don't. It's completely up to you, but a lot of times it's very useful for if you aren't positive that you're going to be getting valid input back. That way you can check for that default value, and or rather, if you don't know if you're going to get a value back or not, you can set it to a default value, and that way you'll know if you've gotten a value or not, instead of just because this initializes or has the ability to initialize to garbage. Okay, so just like we have cout, we want to get information in from the console, so we have cin. Now the pipes go the opposite direction, and we want to put what we get from the user into our number variable. Then we're going to print out the number you have entered is, and we want to put quotations around this number, but you notice when I put that quotation inside of the quotations, it thinks that this is the end of that first quotation, that first string, and that this is the beginning of the second string. So what we have to do is what's called escaping that special character. So all we have to do is just right before the special character, we put a / like that. And you notice our return statement comes back the way it's supposed to. You can, there are lots of special characters that you can use this with. We're going to start off this line with a new line, which the new line character is just a /n. So that'll put a new line right there at the beginning of this line. Now, we want to put our number inside of those quotations, so we pipe that in right after that, and then right after that, we pipe in another string with another quotation mark, and we'll even put a period there so that's proper grammar, and then we end line so that it all gets flushed out. Now it will automatically get flushed out. This right here gets flushed out when it hits this cin, and this would eventually get flushed out anyways automatically, but this end line tells the computer, okay, now is when we want it to go ahead and flush. This is a good time to flush, so go ahead and flush. So let's see how that works out for us. We're going to go ahead, let me stop that, and split this, open a shell over here. We're in our tutorials directory. We're going to build this source file into toot2. No compiler errors, always a good thing. Asks us for a number, let's say 12. Ta-da! You notice there's the new line character at the beginning of it, and our 12 is surrounded by quotation marks. So, what to do next? Well, let's talk about different variable types. For one thing, there's also, if you want to be able to handle decimal places in numbers, you can use either float or double. Double is a double float, so it's bigger, basically. Can handle more precision. Double precision is actually what it stands for. It's a double precision flip. Anyways, if you need, let's run this again, but this time I'm going to put a huge number in there. And you notice that number that we get back is incorrect. That's because every variable has a limit. It's only allowed so much memory to hold information. An integer just so happens to not be very, I mean, it's big, that's a big number, but it's not the biggest. So it's easy to show that off. So if we wanted to be able to handle a bigger hold number like that, we could use long. And then you can also use, if you need really, really long numbers, then you can do long. Anything past that, if you're getting into numbers bigger than that, then you're probably going to be breaking it up into parts just to deal with it anyways. So past that, it's not a huge deal. There's also Boolean, which can either be true or false, and that's it. And char, or char, as some people call it. Let's see what that does, because that's an interesting one. Let's go ahead and recompile this and rerun it, and we'll just put GH. Now you notice it gave us back a character. If we had put in a number, it would have given us the first number because it's the first character. Char or car, however you want to pronounce it, stands for character. Now you can use that character. It's a it's one character from a string. When we type in, we're typing in a string, and it's just that first character. Each glyph in a string is a character in that string. If we wanted to handle a string of characters, we could do string. Then we should also include the string library. And then we can put whatever we want in here, and it gave us up to the first white space because that's the way that CN works. String is not, it is and it isn't a built-in type. Int, char, bool, float, long, and all of those are built-in characters. Now one thing we can do is say we want a second variable, but this one is just our key for something. So we're just going to call it key, and we're going to set it equal to some key that we have that we need for a service somewhere. Now we know that this is a string, and we could set this to string. But in C++11, we got this new thing called auto. And what it does is, later on you'll see that there are much more complex types that you can use, such as iterators and things like that. When you get into the standard library more and get into the data structures and all of that, you can get into some really gnarly looking, and templated programming, you can get into some really gnarly looking type names. So auto takes care of that for us. As long as the compiler can deduce what type that variable is going to be, then we don't have to tell it explicitly what type that variable is. We can just say auto. So in this case, we are setting it right here, so it knows exactly what type this variable is. So then we could see out our key just so that you see that it worked. Key inline. Save. Oh. Not declared in scope. Oh, right. Oh, I promised you that I would teach you how to use C++ or compile C++11. Here you go. You have to add standard equals C++11, and now you see it compiles correctly. If you don't add that, and it's not the default for your compiler, as it isn't in my case, then you'll run into issues. So now you see we get our string back, and we get our key down here. So the limits for the variables, there are charts for them, but it also varies based on CPU platform. ARM's going to have a different chart from a 64-bit processor from a 32-bit processor. There are some standards, but the platform is dependent on the platform. So you'll have to check a chart or look at that. Now you notice this char star up here. The last type that we're going to get into is called a pointer. It's the last of the built-in types. And it is a pointer to a place in memory. The type ahead of it is, so for instance, in this case, char, is telling it how big each slot of memory in it will be. So we're pointing to a place in memory, and this is a little complex, and we'll get into this more later, but we're pointing to a place in memory, and then each nugget of memory for that this pointer is going to point to will be of size char. So let's see what that does. You notice it behaves exactly the same way as the string. And that's because more or less in the background, the string is more or less a char star. Alrighty, so I hope that helps you guys. I'm gonna again continue to try and make more of these remakes with the C++11 standard. If you have any questions, please feel free to comment below. Please like, subscribe, favorite. You guys have a good day.